guys, here's my solution to the second experimental design practice question. So there are actually 6 treatments that are going to be used in this experiment. Each treatment is a combination of 2 factors. The growth enhancing nutrients, that's the first factor. It has 3 different levels, A, B, and C. The second factor is the salinity level. It has 2 levels, low and high. So notice for each nutrient, for instance A, you can have low or high salinity. For B, you can have low and high, and same thing for C. You can also have low and high salinity. So combining these 2 factors, there are 6 unique combinations or 6 treatments that we need to assign in this experiment. So we have A and low salinity. We have B and low, C and low. Then we have A and high, B and high. Again, that's high salinity. C and high. 6 treatments. So by far and away, the most difficult part of this question is part B. What's important is to be very specific here. So using the treatments listed above, so there are 6 treatments, describe a completely randomized design, so it's very important that your design is random, that will allow the biologist to compare the shrimp's growth after 3 weeks. So what I need to do is make sure that there are 12 tanks. Each tank already has 10 tiger shrimp in it. So something to think about, you can't individually take shrimp and apply treatments to them. The shrimp are already in 12 groups or 12 tanks of 10. So a much more efficient procedure is to assign the treatments, there are 6 of them, to the tanks. That means that each treatment can be assigned to 2 different tanks. So since there are 6 treatments, I thought about numbering the treatments 1 through 6. This is certainly not the only way to answer the question. So I just like this answer because it's an alternate strategy. Instead of using a hat or random numbers, we can roll a die, a 6-sided die. So number the treatments from 1 to 6. So then I wrote roll a die for each tank. So of course this die should be a 6-sided die for each tank. So the number on the die corresponds to the treatment to be assigned to the tank. So if I roll a die for the first tank and it comes up a 5, treatment number 5, growth enhancing nutrient B and high salinity would be the treatment applied to that tank. So for the second tank, I will roll again, apply the appropriate treatment to the second tank. But you have to qualify this. Once a treatment has been assigned twice, if its number appears for a tank, it should be ignored. The die should be rolled again to randomly select a different treatment. So once a treatment has been assigned twice, it can't be assigned again. That number, if it reappears for a tank later on in the sequence, that number should be ignored, and you should re-roll in order to get one of the numbers where there is still a treatment left to be assigned. Follow this procedure until all tanks have been assigned a treatment, 2 tanks per treatment. So what I care about here is you are using a specific method that is random. Rolling a die is considered a random method, but you have to be specific here. And I guess the trick to this question, and what makes this question a little bit more difficult, you can't really assign the shrimp to the treatments because the shrimp are already in tanks, 10 tiger shrimp per tank. So really the best way to do this is to assign the treatments to the tanks randomly. So the most important part of the question though, part C and D, give one statistical advantage of having only tiger shrimps in the experiment. Explain why this is an advantage. Well, the statistical advantage, what we've done here is we're essentially reducing the variability in the subjects. Think about this. All of the subjects are similar genetically. They're all tiger shrimp. So by reducing variability, that's the statistical advantage. The reason why this is an advantage is because it allows for a more genuine comparison of the 6 treatments. If there actually is a difference between the 6 treatments, we should be able to recognize that the difference is because of the treatment and not because of differences in the shrimps themselves, because all of the shrimps in the experiment are tiger shrimp. So the best answer to part C talks about comparison. That would be a key word to use in an answer to part C. I can make a more valid comparison regarding the effectiveness of the 6 treatments because differences in the treatments, differences in the response, in the essentially growth of the shrimp is not because there are different types of shrimp. They're all tiger shrimp. So I can attribute differences that I see to differences from the treatments themselves. Answer C is really all about talking why I have a valid comparison here, a genuine comparison. So part D, there is a statistical disadvantage to having only tiger shrimp in the experiment. Explain why this is a disadvantage. It would be great to do this experiment to decide which of these treatments for shrimp in general will help those shrimp grow. The problem is you won't be able to generalize the result to anything but truly tiger shrimp because the only subjects used in this experiment, the only experimental units in this experiment are tiger shrimp. So the disadvantage, you should write about the fact that you will not be able to generalize this result to the population of different types of shrimp. So you can't generalize the result. You can't generalize the result to other types of shrimp. Again, you should recognize the notions here in part C and part D. Experiments in the end, the goal is to have a valid comparison between the responses to the treatments. So using only tiger shrimps reduces the variability in the units that I'm experimenting upon. So I believe differences in response are actually due to the treatments and not due to the experimental units themselves. Answer C is about comparison. But of course, the trade-off is you can only generalize this result to tiger shrimps. I can't generalize the result to other types of shrimp that because of the way those shrimp are, even genetically, they are different from tiger shrimp. They may not react to these treatments in the same way. Although I gain better comparison, I lose the ability to generalize. And that's the trade-off that you're being asked to write about when you consider parts C and D.